Morning Year 6, hope you had a wonderful weekend. Next video here on statistics specifically, looking at real life graphs and line graphs. I haven't really got huge amounts more to teach you now from the curriculum, so we're coming near the end, which means we'll be able to revisit some things we've done before. And then also I'll look at pushing you on as well and setting you some harder work, but we're still in the main curriculum of what you need to learn in Year 6 at the moment. So following on from last week, I will be doing conversion graphs again at some point because there was a real mixture of scores of how people did with that. So I'm going to revisit that at some point, just so you know. Okay, right, graphs, specifically here looking at real life graphs. Well, looking at this graph here, what can we tell from this graph? Well, okay, I know it's to do with time up to about 70 seconds, and also speed as well in kilometers per hour. I've got point A, point B, point C, point D. So at some point it's slowing down, at some point it's accelerating, and at some point there's a constant speed. Well, it's clearly accelerating at that point there. At point A, it's getting quicker. Okay. At point B, there is still an acceleration because it's still getting faster. You can see we're increasing from 0 kilometers per hour to 50 kilometers per hour, so it's accelerating, we're going faster. And then again at point B, we're accelerating from 50 kilometers per hour to 75 kilometers per hour. However, point B is a slower acceleration than point A, because if we look at the gradient, that's the steepness of the graph, the gradient of A is very steep, whereas the gradient of B is more like that. Okay, so we can tell that this point here, A, is quite steep, so it's a quick acceleration, and point B, this point is a less of a is more of a slope. Okay, it's not quite as steep, therefore it's a slower acceleration. Well then, okay, coming back to this point, point C is at a constant speed. There's no acceleration, it's not going up, it's not going down, so it's a constant speed. And then finally point D, then it's decelerating, we're going slower until eventually we reach a point of 0 kilometers per hour. Okay, now this graph, again, funny looking graph, but we can tell at some point it breaks, some point there's a constant speed, at some point it stops, and then there's another point where the acceleration is increasing as well. And again, we've got point A, point B, point C, and point D. Now, A then, this funny looking graph that goes sort of like that. Well, it's accelerating, definitely. It's not accelerating at the same rate though, because if we notice on the last graph, it was a line like that. It was a straight line. This line is not straight, it's curved, which means the acceleration is happening. We know it's accelerating because we're going from 0 up to just above 50 kilometers per hour, but it's curved, which means there's a different rate of acceleration. So at some point they've got the pedal down a lot, and at some point they've got the pedal down just a little bit. So this is where the acceleration then is increasing at point A. Okay, the acceleration is increasing because we've got that curved line. Okay, so the acceleration is happening, it's getting faster, but it's curved. Okay, well, point B, same as last point, a long time where they have a constant speed. We know it's a longer time because if we go down and go down, obviously that's quite a long time there compared to the others. Here we've got it decelerates quite quickly, so we've got a hard break here, point C, and then point D, it's suddenly there is no movement in speed, it just stops, it goes directly to 0, so it's braked hard, and then there is no further travelling, so it's the stopping motion. Okay, so you can tell a lot from the shape of a graph and what it means. Now, question 2, you've got, I'm not going to go through all of these, but it's looking and understanding what the real life graph is showing. So what was the temperature at 9 AM? Well, you know, at 9 AM you would get your ruler out and you would draw up from 9 AM, okay, and then you'd go along to the y-axis, and I would say that that's about 40 degrees Fahrenheit. So in there we would type 40, okay? What was the difference? Well, difference is key between 7 a.m. and 5 p.m. So we go to 7 a.m., which is exactly there, starts at 35. 5 p.m. if I draw up and go along, 50. So between 35 and 50, there is a difference of 15 degrees Fahrenheit, okay? Now I'm going to jump down to here. In which part of the day was the temperature the fastest rising? Well, you're looking for that steepest gradient, that steepest curve, okay? And where is it the steepest? Now, we've got this point here, which to me looks the steepest because that's fairly flat, okay? It's increasing slightly at point B, but point C, I would say, is the steepest of where its temperature is increasing. And which part of the day was there the least change in temperature? Well, you're looking for where that curve is going to be the flattest then, okay? Because that's where it's going to be not really changing too much, and I would say that that is more point A, okay? So fairly straightforward, those questions, and we did do a bit of that last year, so it is revisiting, okay? Now, moving on to line graphs then. The children in Dial class complete a science experiment. They've measured the temperature outside their classroom throughout the day. The results are shown in this table here, a nice simple table. Okay, not particularly nice to read though, you can't really tell a lot from that, so we'd want to put it in a graph. Now, which graph best represents this data? Well, straight away, the pie chart, which is coming up for us to study, is not particularly easy, certainly not the pictogram. It's between these two, I would say, but I'm going to go for this one here as the easiest for us. That one is, okay, you can tell, but this one's clear to get a trend of what happened throughout the day, okay? Now, moving on. Why, though? Why is that the best graph? Well, if the information you collect, so here we were collecting information about temperature, okay, so if the information you collect is a measurement, well, we have measured the temperature, we've used a thermometer, okay, it's called continuous data. So for example, outdoor temperature, the speed of a car. So if we go back to this one, it was a continuous data because we were measuring in kilometers per hour, okay, also the height of a plant as well. You would measure that height of the plant. So again, that would be continuous data. So it's called continuous data if you measure it, okay? And it obviously doesn't have to be physically with a tape measure. You can measure it with whatever means needed. So the speed of a car, you'd measure the speed. The outdoor temperature, you'd measure the temperature, okay? Now, these three types of graph are best for representing discrete data. So that's data that you don't measure. Okay, so the pie chart, the bar graph, and the pictogram. Okay, discrete data has a limited number of values, such as days of the week or colours. So really discrete, there's only one possible option. So it's either Monday, Tuesday, Wednesday, Thursday, Friday. It's either 6 a.m., 7 a.m., 8 a.m. Okay, for measuring those. Okay. So that's discrete data, can't be measured, it's set. Continuous data can be measured, there's almost a whole range of values it could be, okay? So continuous, I think it's continuing, so it's quite easy to remember, and discrete is not. Now moving on then. So question one asks you to plot this line graph. Now I'm not going to go through all of this, I'm not going to insult your intelligence. 1 month, obviously it's 2, so I go up 1 and y is 2. 2 months it was 3, so these basically become coordinates, don't they? Go along 2, up 3, okay, and I go 3 along 6 up, 3 along 6 up, so that was quite a big rise there. 4 along 7 up, and then not a big rise between age 3 and 4 months, okay. And then you would plot those, and that's easy to do. You'll be fine with that because you're all good scientists, okay? Pointing out as well, just to develop your science ability, when we're choosing which axis has which piece of data, usually the y-axis is the data you're measuring. So in this case, we're measuring how heavy the dog is, okay, how heavy the puppy is. When we go back here, we were measuring the speed, so it was on the y-axis. If we go back to the temperature on here, okay, we were measuring the temperature, so it was on the y-axis. So the y-axis is usually what you're measuring. It's called the independent variable. Okay, and down here is not what you're measuring, which makes it slightly easier. And then obviously, once you've plotted all those, you would use a ruler and you would join them up, and that's what a line graph would look like. Okay, now how far had the runner travelled after 20 seconds? So how far had he travelled after 20 seconds? So again, I would go down from 20. Okay, so that's that point, and go along. Okay, and then I would go from this point here. It doesn't specifically ask when it ends, so you would then just work out the distance that he's travelled. Okay, how long does it take the runner to run 100 meters? So I need to go along 100 meters. Here it is, that's what I'm measuring. Go along, and then go down. Well, clearly then it took him 30 seconds, didn't it? How long does it take him to run 130 meters? Well, 120, 125, 130 would be this point. Go along and go down. It took him 45 seconds, okay? And then a couple of other questions there as well, but in which 10-second period was the least distance covered? Well, we want least distance, so we're looking for the shallowest line, not the steepest, because that would be the most. We want the shallowest line we're looking for, and that would be your answer, and you're looking for that 10-second period. So S is between, so from, for example, 50 seconds to 60 seconds. Okay, we would type in there. Okay, so hopefully all of that is fairly straightforward for you, nothing new particularly, just understanding what we're going for. Of course, if you've got any questions, you can send me a message, and the next set of My Maths will be set for you on Wednesday along with your next video. Okay, so I look forward to seeing your scores. Speak to you soon.